Here we have midterm exam 1, problem number 4. A particle with a mass m and a charge q negatively charged at initial position is x is equal to 0. And with initial velocity along the x-axis is given. So that means our charge is basically has initial velocity and its position at x. Basically, it's moving, okay? It's moving from left to the right, okay? Now, when x is equal to 0, it has initial velocity. And then it starts decelerating by uniform electric field. We have electric field there. Define the maximum position x reached by the particle before it stops. So basically, you have to find a certain distance x where the final velocity will be equal to 0 and it will stop. Now, since we know that electric field is pointing to the right, that means he is negative, he is a positive. Therefore, our charge will start decelerating. At some point, it will stop. Now we have to find what is the maximum distance that particle is moved just before stopping. So how can we find it? Now we have a formula where force is equal Q times E, okay? And we also know is equal to the m times acceleration, okay? Then we have a formula where V final squared is equal V initial squared. Now it's decelerating, so therefore I put here negative 2ax, okay? At some point it will stop, so therefore final velocity becomes 0. Then we have V initial squared is equal to the 2ax. Then from here we can say that acceleration will be equal to the V initial squared divided by 2x. Now we take this this formula and plug it into acceleration. Then we should get that it will be QE is equal m times V initial squared divided by 2x. Then here we have to find just x. So x is equal m V initial squared divided by 2QE. Now if you plug the numbers, you should get the answer.